We're now going to learn how to use our calculator to find the values of the inverse trigonometric functions, inverse cotangent, inverse cosecant, and inverse secant. Let's go through some examples. We're first going to compute the inverse secant of 3. That means that theta equals the inverse secant of 3, so that the secant of some angle theta equals 3. Now what we need to remember is that the domain restriction on the angle theta is that theta has to be between 0 and pi, but theta cannot equal pi over 2. So what we're going to do is convert the secant of theta equals 3 into a cosine. The reason we're going to convert this into a cosine is because the domain restriction on the cosine is the same as the domain restriction on the secant. That's going to be important. That has to be the case in order to use the calculator. So we have that the secant of theta is equivalent to 1 over the cosine of theta. So 1 over the cosine of theta equals 3, which implies that the cosine of theta equals 1/3. Therefore, theta is going to equal the inverse cosine of 1/3. So what we're going to do is enter this expression into our calculator with the calculator in radian mode to find out the angle theta. So we check the mode and we see that I am in radian mode. Then I press the inverse cosine of 1/3, hit enter, and we get 1.23. So the value of theta is about 1.23. Hopefully it's evident to you why we need to make sure that the values of the domain restrictions on the values of theta have to match up, because our calculator only has inverse sine, inverse cosine, and inverse tangent. When it computes one of those three values, it needs, or it's already got, the domain restrictions imposed on the trig functions. So that the outputs match up, we have to have the matching of the domain restrictions. Let's do another example. We're going to compute the inverse cosecant of -4. So theta equals the inverse cosecant of -4, which means the cosecant of some angle theta equals -4. Remember that the restriction on the domain for the cosecant was -pi/2 to pi/2, where theta cannot equal 0. We can recognize immediately that this is the same domain restriction that we had for the sine function. And it's easy to convert cosecant to sine because 1 over sine of theta is the cosecant. So 1 over sine of theta equals -4, which means that the sine of theta is -1/4. Therefore, we're going to say that theta is the inverse sine of -1/4. And if I enter that expression into my calculator, I would get that theta is about -0.25. Now these two examples were pretty simple to do because it was just a question of computing a reciprocal to get a function that had the same domain restrictions. However, it's not always that straightforward. Consider the following example where we have the inverse cotangent of 1/2. That means that we're looking for an angle theta whose cotangent is 1/2. Remember, the restriction on the domain for the cotangent function is that theta is going to be between 0 and pi. Now that is, for all intents and purposes, except for the endpoints, the same domain restrictions that we had on the cosine. So we can't just go ahead and say 1 over tangent equals 1/2, because the domain restriction on the tangent, you recall, is negative pi over 2 to pi over 2. So what we need to do is convert this expression into an equivalent expression involving the cosine function. That's going to be done by drawing our picture with the adjacent side being equal to 1 and the hypotenuse equal, the opposite side equal to 2. So I'm sure my scale won't be drawn exactly, but just bear with me here. We know the angle theta is in the first quadrant because the cotangent's positive. So I need to find my hypotenuse. If you work that out, you should get the hypotenuse is square root of 5. So saying the cotangent of theta equals 1/2 is equivalent to saying the cosine of theta equals 1 over the square root of 5. So we have the following situation. Theta is going to equal the inverse cotangent of 1/2, but that's equivalent to finding the inverse cosine of 1 over the square root of 5. And if we enter that into our calculator, we would get about 1.11.